Hello guys, if you like my awesome gaming videos, my programming and web development courses, my editing courses and editing videos, and my tech talks and tech guidance, then you can consider subscribing to my channel and click on this bell icon to stay connected with me all the time. Hello guys, welcome to my channel. So this part is actually the queue data structure. So in the previous video, if you see, I have worked with the stack.js, which is actually the stack data structure. I have used the object oriented way to implement the stacks and all the thing that I have showed you, which will make you a very good JavaScript developer. And I have implemented all the logics like push, pop, pick, empty, size, optimize search, how can you optimize the searching, and the complexity analysis and all of those steps. Okay, so make sure you see this video, very important. And I will also work with the queue data structure in today's video. Okay, so this is very important. So let me go and create this. So it should be queue data structure.js. okay, so this is the part where I'm going to understand the queue data structure today. Let me show you what the queue data structure basically is. So normally it has two information, one is front and one is rear. Okay, so this is a very important thing. If you want to understand the queue data structure, first you want to understand all the terminologies, like is front, is rear. Rear is actually the ending part. Okay, so we have a bus stand here. So suppose we have a bus stand here and all the people are just standing here waiting for the bus to come. Okay, so these are all the peoples. So these are all the people. So suppose this and this and this. So this is the ending. Okay, so the guy who entered, who is here, is the last guy to enter in this bus. Okay, so the queue data structure maintains the FIFO data structure, FIFO method. FIFO, first in, first out. The people or the guy who entered into the waiting list to get into the bus. Okay, so this is the guy who entered into this waiting list first. So this guy came in first. Okay, so he will get into the bus first. So this is the most real and practical scenario because he is in this bus line at the first. So that's why he will go into this bus faster. Okay, and this guy is on the other end of this bus standing or ticket list. Okay, so this guy is in the end of the line. So basically in practical scenario he should get into the bus in the last. Okay, so this guy is in the last, go into the bus in the last. Okay, so this is actually the rear. Okay, rear. So if we want to pop out some information from the queue data structure, this is the thing. Okay, so let me color in blue. So this guy should be popped out first and we call it DQ. Okay, DQ means actually in the stack, as I have shown you there in the stack.js. As you can see, we have push and pop method. Okay, a push and pop method, which is very important. But here for pop you will use DQ method, and DQ will remove the element from the first index or the guy who is standing in the front. Okay, we call it front. This guy is staying in the front of the list. Okay, so he will be removed or DQ'd first. Okay, he will get into the bus first, then we'll go to him, then the third person, then fourth person, and finally we get the last person. So this guy would get into the bus last. Okay, so this guy is staying at the rear end. Okay, so we have two things. Who is at the end is the rear, who is at the front is actually the front. So we have to remove someone from the front. We have to remove someone from the front. Okay, and we have to add someone. We have to add here, I can add multiple people here in the rear. So when you add some element or DQ or NQ some element, we call it NQ. NQ means adding some information, like push some information into your array or queue data structure. So when you want to add someone, when you want to add some element in this queue, you have to add it into the rear, and make it ++, because it will increase the size of the queue. So that's why you have to increase the number of the rear count. Okay, when you DQ someone, when you remove someone from the front, you can only remove someone from the front, and this would be increase front ++, because you are removing him first, then this front would be stored here, then it will come here, then it will come here. So we are increasing the front. Also from the rear, you are removing him, then you need to increase the rear, and rear would be here, and then rear would be here, and rear would be here. So rear can also be increased here, or you can do decrease. But normally I here in this project I'm going to implement the plus way. So in this video we're going to implement the ends empty functionality is full. It will check if the queue is full, or is empty will check if the queue is empty or not. DQ means remove some element from the front side of the queue. As you can see, this is the most important. When you want to remove someone or some element from the queue, it should when you DQ something, it should be from the front side. Okay. And in the stack it was from the back side or back end, but for the queue it should be removed from the front. And for enqueue it insert element at the end of the queue, which is actually the rear. We call it rear. And front, it will give you the element from the first index or the first element of the queue. Okay. And rear will point to the last person. Okay. And size will give the total size of the queue, and print for printing all the information. So let me run node queue.js. Make sure you have node.js installed, and also you see my JavaScript playlist as well for JavaScript logic building and the stack data structure, because I also implement the stack data structure similar pattern, okay, similarly, so that you can understand it better. So you have to understand the stack data structure first and then come to queue, so that you can understand it much better. So normally the queue data structure takes some parameters, like it have its rear, front, and items for storing all the information. Especially when we work with the JavaScript, you have to use this thing. So first one, let me create it with a class of queue. Okay. Similarly, so if you don't understand the object-oriented way, this is a very simplest way how to implement the queue data structure. You just create one more class and call all the methods and functionalities. Very simple. So first one is the constructor. We have to create a constructor and give a maximum size of suppose 5 by default. Okay, so this dot max size is equals to, or you can give your own size. As you can see, this is the property. Whatever you give, it will be instantiated onto the maximum size. And this dot, we have a front, and keep it -1. In the beginning, it should be -1, and rear, it also should be -1. Simple. And we also need a data structure to hold all the information. It should be items. You can call it queues, whichever, and make sure it is empty in the beginning. So this is our constructor. This is actually the building block of our queue data structure. It has front, it has its rear, it has its items that you need, and it has its maximum size. Similar to our stack. As you can see in the stack, we needed the top element so that we can keep track if it is empty or not, and we needed maximum size and stack. Okay. And for the queue as well, we need two more information, which is the front. We have to keep track of the rear and the items to hold the data. So first one is in queue, we don't call it push, it is actually enqueue. Okay, it is actually enqueue. So to enqueue, we have to check something if it is full. If the queue is full, you cannot add any item to the queue. So this is very important. So how we will check it? First, we have to check if it is full. Okay, we have to check if it is full or not. So is full. Okay, it doesn't take any parameter. So it will check if this dot items dot length, if our total items in the queue is equals to the maximum size, which is 5, it is greater, is equals to 5, it means that it is full. You cannot enqueue any other information or data into this queue data structure. So in that case, you can console.log queue is full. Okay, you can't add any more information here. This is very important. So this is the logic we need, and we also need one more logic to check is empty. Okay, so this is also very important. As you can see, we are implementing the is empty and is full to check if we can implement the DQ or NQ functionality. You have to check these two functions first. Is empty also doesn't take any parameter. Here we have to check if it is empty or not. If our this dot items dot length is equals to 0, it means that it's empty. So we can copy this console.log and paste it queue is empty. Okay, when it is empty, you cannot pop some information or you can't dequeue. Okay, because there is nothing. And for to enqueue, we have to check if it is full or not. If it is full, or it is equals if its length, items.length is equals to the maximum size of the queue, then you cannot add anything. So that's why you need two information. One more thing which is very important, which is the size of queue. You can get it easily, which I can call it size, and it will also return this dot items dot length. Okay, this is the length of the array. As you can see, this will find as the length of the array if you call this method. And so we have completed the is empty, size, and full. This is all similar, very easy and easy stuff. If you see the stack videos, stack data structure video of mine, you will understand it very simply. Now we have to implement the main feature, which is our enqueue and dequeue feature. Okay, so we have to get that. So let me call it enqueue, and it definitely takes some information, some value, so that we can enqueue something. First, it have to check if it is not full. So we have to check negative sign and is full. So if this is not full, then we can, is full means it is full. Okay, it is equal to the maximum size. And if I have added a negative sign because it checks if it is not full. Okay, when it is not full, then you can put some information. So what we can do, we can go to this dot items. Here in the items, here we have to put some information. Okay, so we have to go and access the element from the this dot items is actually the array. Here in this square bracket, you can access some information like a 0 index, 1 index, 2 index, whatever. Here I have to access the rear because we are adding the element in the rear when you enqueue something. Okay, so in the first illustration I have showed you that if you want to add something, you have to enqueue at rear. Okay, you have to enqueue at rear. So here, what information I want to put at what index? So if we go to the items and index of this dot rear, okay, because we are adding the information, putting the information or enqueuing the information at the rear. So this is the index we are going to put some information into this array. So here I'm going to input value, whichever value user typed or user given. Okay, this is the value that we want to add. So this is similar to, suppose we have an array. Suppose we have an array here, index of I. If we want to put some data, assign some data 10. Okay, so this is actually means that this array is actually this dot items, and this index of I is actually which parameter I want to input some value. This rear, at the rear end I want to put some value. So into this index. Okay, I have to put this value which the user gives. Okay, so this is very important. And then we have to increment the rear minus minus, or suppose I will give it plus plus. Okay, here, because the rear would be gone from this place to this place. Suppose we have 10, 20, 30, 40. This is actually the rear. This is actually the rear. When you add something, the rear should increment. Suppose I have added 50 here, our rear is increased 1. Okay, so it will work like that. So we have implemented the enqueue, and let me call this. Okay, so we have to write const queue data structure, and we're gonna name it new queue data structure, and you can give it, define it any size, but in the default parameters of the constructor I have given it 5. Let me give it 3. Okay, so that we can check other parameters. So here we will call it queue.enqueue, enqueue 10, and queue.enqueue 20, and queue.enqueue 30. This is the length of the enqueue. 0, 1, 2. We can add only 3 information because our maximum size, as you can see, is 3 in the constructor. So now we have to console.log this. To console.log, we have to add one more function to print this. Okay, so to print this, we can write console.log this dot items. Okay, so this will print all the informations. So here we can write queue, And to access this item method in object oriented way, as you can see, I have created the instance of it. Now I am just calling it and adding some value. And here I need to print. Okay, so in the array I should have three information. First we have 10, which is added to the first, then we have 20 and 30. This is the waiting list. This guy should get into the bus first, then 20 and then 30. Okay, similar to that. Okay, note, so as you can see, okay, 10 30 20 30 minus 1 10. So we have to add this dot rare in the beginning. Okay, we have to increment it first, then we need to add this data, because in the beginning the front is actually -1, so you cannot put information into the -1 index. So we have to increment the rare first, so that it goes from suppose -1 to 0, then it will work. Okay, so it is important, because for the array in the -1 index you cannot put some information. You have to add it first and make it 0 in the beginning to add some data. Okay, so that's why there is some problem. I think it will be fixed. As you can see, first we have added 10, then 20, then 30 very easily. And then what you can do, you can print this out. As you can see, this is the thing that we have printed. Now it is our main duty to dequeue something. Okay, and here I'm going to implement dequeue at front, because we have to dequeue in these data structures of queue. We have to dequeue or remove some information from the front. Okay, so here we have to dequeue the information from the front, and we have to check if there is something, if we have some value. Okay, if it is not empty, if it is empty, that you cannot dequeue. So we have to check if is empty and make sure it is negative sign, because if it is not empty, then you can dequeue something. Okay, this is the important, and this is the main checking. This is why you need logic building in JavaScript and in data structures. This is the thing data structure shows you, how you structures your data, how you remove something, add something, and create something, and you have the logic. If it is empty or it is full, you have to check every single thing. Okay, so this is the logic that makes you a better programmer, better engineer, and a better developer as well. So this is very important thing. So here I'm checking if it is not empty, then you can remove something. You cannot remove something if there is nothing. There should be something, okay, to remove. So we have to do this. Suppose what we can do, we have to remove something from the front. So we need to go to this dot, suppose we can name it const item, whichever the item we want to remove. Okay, so we need to go to this dot items, and here this dot items, we are going to this array, and we need to go to this dot front. Okay, we are removing something from the front index. Okay, and what we can do, you also need to increase it. Suppose front plus plus, front, this dot front plus plus, because in the beginning the front is -1, so you cannot remove anything from the -1 index. Okay, you should also increment it first. We can return that element, or you can name it element for better understanding, because we already have this items array in our queue data structure, as you can see. So it is better to name it different way. First, what we are doing, we are going to the items array, and we are removing what we have in the front index. So front, in the beginning you cannot make it -1. Okay, here you cannot remove anything from the -1 index. You make sure you increment it by 1 and do it. Okay, when this logic is successful, it is not empty, then you can also do this. So our dequeue is successful. Let me check if it is working or not. Queue object or queue dot dequeue. Okay, you can dequeue some information, and it will dequeue 10 because it is in the first index. He is waiting for longer in the ticket counter. Okay, so he came to the ticket counter faster. Okay, and he should be removed faster. Okay, so let me just do this. As you can see, 10 is removed, and final result is 10, 20 and 30. The 10 is not removed because I have not add one more line of code which is important. After you just remove the front element and return this, you have to use this .items.shift method. Shift, what it does, removes the first element from an array and returns it. If you use pop, it will not work because pop removes the last element, which we don't want. In queue data structure, we have to remove the element from the first index, so that's why we need shift. So now it will give you the proper result. As you can see, the 10 is removed. We have 20 and 30. We'll call it 2 times. First 10 would be removed, then 20, and we will have only 30 left. As you can see, 30 is alone left in this queue data structure, and 10 and 30 are removed. So it works really fine. Then we need 2 more function, and let me call this size. Okay, so let me call this console.log queue.size. It will give us the size of our queue data structure. So let me check. As you can see, 1, because we have only 1 information, so our size is 1. If I just dequeue only 1 element, then it should be 2. As you can see, 2. So it works without any issues. We need the front and rear. So how can you get the front? To get the front information, we need to get return this .items. Here we have to get this .front. We need to get the items from the front index. So let me call it and let's check it out. Here console.log, you can use front queue.front. Let me check. Okay, there is some error. Let me check this. Just queue to the structure. You can name it front. Okay, because we have 2 front here. This is another front and this function name is front, so there is a confliction. So you can make it uppercase front. It should work. Queue.front. Okay. So as you can see, this is the front. Now because 10 is removed, we have 10, we have 20 and 30. So 20 is actually the front and 2 is actually the size, the queue. So very simple steps. Just don't make mistake of this thing. Just don't give the same name to property and the function. It will have some problem, and this should be rear. If you want to find the rear element, you can easily do it. So these are the logics. This is very simple stuffs that you can do. And also this should be coming from our rear index. So go to the items and get this index value, get the rear. Okay, and just return this and this. Okay, and let me call it, and here it should be queue.rear. We need to get the rear item. The rear item is actually 30 here, so it is showing undefined. Okay, we need to get the rear element. So as you can see, it shows the front value, but it doesn't show the rear value. The rear value should be 30, and you can use -1. It will go to the last index. Okay, I think now it should work, because in the array you should go to the last index -1. So it will give you the last information on the last item, which is stored in the rear, because in the rear we need the last element which is stored in the rear, okay, in the queue data structure. And in the front element, it should be into the front, okay, of this data structure, and it will get the front value. So let me just save it, and as you can see, this is the 30 is actually the rear, which is this, and 20 is actually the front in this array, because 10 is actually dequeued. So let me check it if it is work or not. If I just check queue.enqueue 40, and suppose we don't want to dequeue anything, and in the beginning I want to print everything, then I want to print this information. So but total size is 4, 0, 1, 2, 3, 4. For queue is full. So as you can see, it shows queue is full because you cannot add 4 information. Okay, as you can see, our maximum size is 3. So if we increase it to 4, then you can enqueue for information. Okay, so this is very important. As you can see, now it works just fine. So one more thing you can do to find the rear is very simple. You need to just go to return this dot items, and in the items you need to just say 0 index, and in the items you need to go this dot items dot length -1. Okay? So return this element. Or in the front, what you can do, you can just return this dot items and get the first index value, which is actually the front. Okay, very simple stuff. And also you can return the last element from the rear. So let me check it out and give me the front and rear. We have 4 information. As you can see, 10 is actually the front and 40 is actually the rear. As you can see, this is 10 is front, 40 is rear. So all of the thing is working pretty fine without any issues. This is a very simple use case of rear to get the last index element. As you can see, we're going to the full items length and -1 to get the last index value, and we are returning it. And for the front, we are just getting the first index value. It also works just fine because you're working with JavaScript. You need to understand these logics. So I have completed the queue data structure and stack data structure. If you don't understand, I will give you the code below so that you can practice it and understand it properly. And from the next lecture, I'm going to work with the binary search tree, which is also a very important thing to learn. And there's a lot of things to learn in binary search tree, and especially the linked list, which is all the custom data structure that I'm going to work on in this playlist for the data structure algorithm with JavaScript. So I think this will make you a better JavaScript developer, better data structure and algorithm. You can implement a lot of algorithm with it if you understand the basic of this data structures and algorithm. I hope this will make you a better developer in general. So I hope you'll take care and bye, and I'll see you in the next video.